Yes, last time what we were studying, we were discussing about the CPU RISC architecture. Okay, so ARM 1176 processor architecture we were studying, and in that we have seen that ARM 1176 processor, which is the 32-bit processor, and it deals with what is called as thumb instruction set. Even though being 32-bit processor, it can execute 16-bit thumb instructions, which are fast instructions. And this feature is included in this ARM processor. And it is capable of directly executing Java bytecodes. And for executing Java bytecodes, it requires what is called as Java Technology Enabling Kit, JTEK. Okay, so the chip also contains this facility. So that is what we have seen here. Okay, so now coming to the next point of this architecture. So here you can observe what you can observe over here. Now we have discussed about this core ARM processor, which follows what is called as ARM 11 architecture. So now we are moving to the discussion of the cache memory. So cache memory consists of uh, two separate types of memory. One is called as instruction cache, another is called as data cache. Okay, and here, as you can see, this cache is of 32 KB. So both of these cache, they are of 32-bit KB. Okay, and the cache is also two-level cache. Two-level cache is there, and for second-level cache memory, there is a memory controller called as L2CC. Okay, so that is level 2 cache controller. So this level 2 cache is having size greater than that of level 1 cache size, which is of size 128 kilobyte. Okay, so level 1 cache is fastest, and level 2 cache is little bit slower than this level 1 cache. Okay, so this is how the cache memory is organized here. After this, what you can observe here is a memory management unit. And as you know, what is function of memory management unit? Can somebody tell me what is function of memory management unit, for what it is used? Yes, do you have any idea? Yes, students, do you have idea for what the memory management unit must be used? Yes, can anybody tell me about memory management unit? If you have studied operating system, you must be knowing there is memory management function, which is one of the functions of operating system. Okay, so it may be in the form of software, it may be in the form of hardware. So in ARM 11 architecture, the hardware memory management unit is provided here, and management of all memory related operations is carried out by this memory management unit. So this type of management unit particularly implements what is called as a virtual memory. You must be knowing concept of the virtual memory. Do you know what virtual memory is? Can anybody tell me what virtual memory is? You have studied memory architecture last year, is it or not? So do you know what is meaning of virtual memory? Can anybody tell me? Yes,
Random access memory.
virtual memory I'm asking. Virtual memory is not a physical memory in that way. Uh, what it does, the computer sees a totality of primary memory and secondary memory as a primary memory. Okay, secondary memory is also considered as a primary memory, and this particularly is used to improve the performance of the processor. Okay, so total space, total primary space considered by your processor is bigger than actual physical primary memory space. So this is what is implemented in case of virtual memory, and such virtual memory is included in this particular architecture to improve the performance of the processor. And due to this, as virtual memory is provided here, the memory management unit will be required for this. And basically, memory management unit will do the function of address calculation. So actual logical address is different from that of physical address. So function of the memory management unit is to convert logical address of your program into actual physical address. Okay, so that is what is done by this memory management unit, and such type of memory management unit is present as you can see here. So here this memory management unit is present there. Okay, now after this, what you can observe here is again some kind of memory which is attached to the data cache, and that is your main memory. Okay, so what the main memory consists of? Main memory consists of random access memory, and this random access memory is called as tightly coupled. It is called as tightly coupled random access memory. So it is coupled with the cache memory. Okay, so in between processor and main memory, there is a cache memory. So this memory is distributed into two different parts: instruction cache, data cache. And again, the main memory is also divided into two parts, one for instruction and another for data. So like this distribution is important to implement parallelism in processor. So parallelism in processor improves the performance of the processor as a overall thing. Okay, so for this reason, the tightly coupled main memory is used here. Okay, now after this, one more thing you can observe in this architecture, and that is here optional VFP. Okay, so this VFP is nothing but vector floating point coprocessor. Floating point coprocessor. Okay, so it is not actual processor like CPU, this one, core one. This is your main processor, and this processor is going to help the main processor, and hence this VFP processor is called as a coprocessor. And basically, this type of processor is used for floating point operations, and floating point operations which are required for image processing. Generally, they are carried out by this VFP coprocessor. So burden of these calculations is relieved by this coprocessor from the CPU. So work is distributed, and therefore there will be performance improvement here. So all floating point operations, they are carried out by a separate coprocessor called as VFP coprocessor, which is vector floating point coprocessor. Okay, so this is very similar to Intel Pentium architecture. So Intel Pentium architecture also has separate pipeline for floating point operations, and two separate pipelines for integer operations, as I told you earlier, and it is one of the important features of this ARM architecture also. Okay, now As here you can observe there is a presence of coprocessor. There is a presence of coprocessor on to this chip. The coprocessor controller must be there, and coprocessor controller is provided here, and it is shown along with the bidirectional data bus. Okay. Now, as you can uh, go to one more feature of this particular type of architecture, and that is what you can observe here, which is called as trust zone enabled. Okay, so what is meaning of trust zone enabled? So trust zone enabling is nothing but the security extensions. So security extensions provided to this main core processor. Okay, and this trust zone security extension, it consists of interrupt controller. Okay, trust zone interrupt controller, which is abbreviated as TZIC. It is present in the processor, and trust zone protection controller is also there. So this protection controller basically it is used to protect various rights of users and system, and a layered protection is provided here, and this protection is called as a trust zone protection. So after this, if you go to another component of this type of, yes, you have any doubt? Yes, anybody? कोणाला काही शंका असेल तर विचारा. जनरली प्रोटेक्शन प्रोव्हाइड करायसाठी म्हणजे एक ठराविक एरिया असतो मेमरी मधला, तो मेमरी मधला एरिया कोण ऍक्सेस करू शकतं, युजर ऍक्सेस करू शकतो का सिस्टीम ऍक्सेस करू शकते, अशा प्रकारचं जे प्रोटेक्शन प्रोव्हाइड केलं जातं ते प्रोटेक्शन हे प्रोटेक्शन कंट्रोलर थ्रू प्रोव्हाइड केलं जातं, आणि हा जो प्रोटेक्शन कंट्रोलर याच्यामध्ये यूज केलेला आहे इट इज कॉल्ड ॲज अ ट्रस्ट झोन प्रोटेक्शन कंट्रोलर. ओके, सो नाव moving to next architectural feature of this, and that is uh, even though it is not shown over here, but it is present there, which is called as intelligent energy management. So there is intelligent energy management provided into this ARM core. Okay, so there is a controller, special controller used for managing power, and this controller is called as intelligent energy controller. So with help of this intelligent energy controller, the power management in the processor core is carried out, and which is very important for the portable applications. Okay, so here basically two types of power controllers are used. One is National Semiconductor Advanced Power Controller, and another is National Semiconductor Hardware Performance Monitor. So it will monitor the hardware performance, and accordingly it will provide power control to the system. So this type of power control is called as intelligent energy management, and this is provided with the help of a special controller in ARM processor. Now after this, what you can observe here is what you can see here is that is AXI interface. Okay, so this AXI interface is particularly used for buses. Okay, meaning of AXI is that advanced extensible interface. Okay, what it is known as advanced extensible interface, and this advanced extensible interface is actually a part of ARM advanced microcontroller bus. Okay, and as this is ARM bus, it has this type of AXI bus interface. Okay, so here you can observe there is a separate interface for instruction, there is a separate interface for data interface, and there is a separate interface for ports, peripheral ports. That means external devices, those you are going to connect to this processor, those are handled by this peripheral port. And as I told you, there is a presence of DMA. DMA means direct memory access. What this direct memory access does, it enables the direct communication between external peripheral device and internal memory, which is present here. Okay, so it enables the direct connection. So this core is not involved here, and again, therefore, the burden from core is relieved, and which contributes to the improvement in the performance of the system. So our total aim is to improve the performance. So to have a high performance, we are going to use such type of AXI bus. And this AXI bus uses synchronous type of communication, serial communication, which is synchronous in nature. So all of you know synchronous communication is a high speed serial type of communication. Okay, so asynchronous is having lower speed, but your uh, synchronous type of bus, it is having higher speed. Okay, and this bus controller generally uses master slave type of communication. So there is a bus controller which is acting as a master, and the remaining all devices which are connected to this bus, they are treated as slave, and control of the bus to different slaves is provided by the controller. So this type of AXI interface is provided on this. Okay, now coming to the next point of this, and that is already we have studied, I think, everything. Certain things are still remaining. So there is what is called as clock control. It is also present on this type of processor. Clock control is used to generate the clock frequency through crystal oscillator, and output of this crystal oscillator is given to a circuit which is called as phase lock loop. So this phase lock loop will ensure the stable operating and accurate operating frequency to your processor core. Okay, so there are memory controllers which are present onto your uh, micro CPU chip. That is what you can say. And even interrupt controllers are also there, because as for the operation of any microprocessor, we need interrupts. So interrupts are the signal which are used for variety of applications, and therefore interrupts must be handled in a proper way. Proper priority should be given to these interrupts, and these things are provided by what is called as interrupt controller. So there is a presence of interrupt controller over there. Okay. Now there is one more controller onto this, which is called as uh, CLCD. CLCD means LCD controller. Okay, so you can interface LCD type of display to this type of processor. So this LCD controller chip, it provides or it supports the VGA type of monitor and digital LCD displays to be connected to this microprocessor. Similarly, UART is also present there. UART means a universal asynchronous receiver and transmitter. Asynchronous type of communication is also enabled through this type of UART controller, and this UART controller internally converts serial data to parallel and parallel data to serial, okay, to be transmitted onto system to peripheral. When we are transmitting from system to peripheral, parallel data must be converted into serial, and when the system is receiving data from peripheral, then serial data will be converted into parallel by this UART type of controller. Okay, now this also has timers which are present on it, and there are 632-bit timers which are present on these uh, ARM processor. Okay, and it is programmable timer, so you can generate time delays as you require. Then there is one synchronous serial port which is present onto this chip. as this serial port is called as synchronous, it supports synchronous type of operation. Okay. Now there is also what is called as a smart card interface, which is present onto this, and this smart card interface is particularly for security identity module. That is, you can insert SIM card into it or similar type of module into it. Obviously, general purpose input output pins are also provided. Okay, and there is one special type of module which is called as watchdog module, and this is used particularly for interrupt system. Okay, and it is used to trigger an interrupt or system reset in the event of software failure. So what is the meaning of the watchdog? Watchdog module is generally used to trigger an interrupt or system reset. Any one of these two things when there is software failure. So when there is software failure, the reset operation must be carried out. Okay, so this is what is there in this particular processor. So are you clear about this? I'm going to give you notes about this. Okay, and I think it is not very much difficult. Just you have to know what is function of each and every block and what is the meaning of each and every block. That only is necessary for this. Okay. Now, now coming to the next point here, what you can observe on the screen. Can anybody tell me what you can observe on the screen?
Pipeline stages used by ARM11.
Do you have any idea what the pipeline is? Do you have any idea? Yes, tell me. If you know, tell me yes. If you don't know, tell me no. येस, बोला की मुलांनो. माहिती आहे की नाही एवढं सांगा मला. माहित नसेल तर तुम्हाला त्याचा इनिशियल कन्सेप्ट मी सांगते आणि मग आपण आर्मच्या पाईपलाईन कडे जाऊया.
नो मॅम.
हा, बर. माहित नसेल तर तुम्हाला मी ही कन्सेप्ट सांगते पहिल्यांदा आणि मग आपण त्या आर्मच्या पाईपलाईन कडे जाऊया. तर जनरली काय असतं की ऑपरेशन्स ज्या असतात ना त्या ओव्हरलॅप करून पॅरललिझम जर आणायचं असेल प्रोसेसर मध्ये तर त्या प्रकारच्या पॅरललिझमला पाईपलाईन असं नाव आहे. ओके, येतंय लक्षात तुमच्या? आता फॉर एक्झाम्पलच घ्यायचं झालं तर आपल्याला समजा इन्स्ट्रक्शन एक्झिक्यूट करायची आहे. ओके, काय करायचंय? इन्स्ट्रक्शन एक्झिक्यूट करायचे आणि इन्स्ट्रक्शन एक्झिक्यूट करत असताना कुठल्या प्रकारच्या ऑपरेशन्स परफॉर्म केल्या जातात माहितीये तुम्हाला? पहिली ऑपरेशन जी परफॉर्म केली जाते ती फेच असते. इन्स्ट्रक्शन फेच केली जाते. Instruction is fetched from the memory. Thereafter, what is done? It is decoded. त्याचा अर्थ कळायला लागतो ना त्या प्रोसेसरला. So initially the instruction is fetched, then it is decoded, and thereafter it is executed. Executed means actual operation is performed. Particular circuits are activated to perform those operations. It is called as execution. For example, suppose if you with help of some processor, if you run the instruction like add AB, So first what it will do, it will fetch this instruction from the memory, add AB. This will be first step of execution. The second step will be decoding of this instruction. That means it will read the code value of add, and from that it will come to know that adder circuit of your arithmetic logic unit has to be activated. And then after decoding, it will activate the adder circuit. And when the adder circuit is activated, it will take data which is present in the opcode field, and these data will be added and it is directed to the destination. So this is what is happening in execution of every instruction. Now, how these operations are pipelined, or how these operations are executed parallelly. So that is what we want to see here. Now, when number of instructions are executed, suppose not a single instruction, but suppose n number of instructions are executed at a time, then particularly this type of pipelining is useful. That means each instruction, suppose if I have instruction 1, instruction 2, instruction 3, instruction 4, instruction 5. So suppose if there are these three instructions, then each instruction is divided into three segments. One segment is called as fetch, another segment is called as decode, and third segment is called as execute. So all the three operations are not conducted simultaneously. Okay, so here instruction 1 is divided into F1, D1 and E1. Instruction 2 is divided into F2, D2 and E2. Okay, then like this, you go on doing this. So this will be F3, D3, E3. So again F4, D4, E4, F5, D5, E5. So this is what is done here. Now how pipeline is implemented, that is what you can observe over here. So initially what is done, initially first instruction will be fetched. Okay, so there will be F1 operation during first clock cycle. Okay, so what will happen during second clock pulse? During second clock pulse, fetching of second instruction and decoding of first instruction will be carried out simultaneously. During third clock pulse, fetching of third instruction, decoding of second instruction and execution of first instruction will be done. Okay, during fourth clock pulse, as you can see here, fetching of fourth instruction, decoding of third instruction and execution of second instruction. So for fifth clock pulse, what you can observe here, fetching of fifth instruction, decoding of fourth instruction and execution of third instruction. Okay, so here for suppose if you go for sixth clock pulse, again here will be fetching of sixth, decoding of fifth and execution of fourth. Okay, now if you consider 5 instructions only, and if you execute this in serial fashion, then you can observe that there are 3 operations needed during each clock pulse. Okay. Oh, sorry. So, if you consider all 5 instructions, then 5 multiplied by 3, 15 clock pulses will be required to execute the 5 instructions. Okay. But if you implement 3-stage pipeline, 3-stage pipeline means there are 3 segments of pipeline. One is fetch, another is decode, and third is execution. So if you overlap these operations, fetching, decoding, and execution, and if you overlap these operations and concurrently perform all these operations, then in order to execute say 5 instructions, how many clock cycles you will require? You will require only 7 clock cycles. Okay, you will require only 7 clock cycles. So suppose if such thousands of instructions are to be executed, then apparently one instruction will be executed per clock. One instruction will be executed per clock. Only overhead of 3 clock pulses is there. 2 clock pulses rather, I can say in this case. Overhead of 2 clock pulses is there. So as 3 stages are there, there is overhead of 2 clock pulses. If there are 4 stages, there is overhead of 3 clock pulses, like this. But if you are repeating these operations for number of times, then you are getting benefit of it, and benefit is that almost for every clock pulse one instruction is executed, and this is which is important architectural feature of the RISC architecture, that is reduced instruction set architecture. So to implement such kind of pipeline, it is important that length of all instructions be same, almost same, and therefore such kind of implementation will provide a simplicity. Okay, otherwise if variable length instructions are there, then it becomes too difficult, it becomes difficult to implement such type of pipelining. Are you clear about what the pipelining is? First you tell me that, and then we will move to pipelining of your ARM processor. Tell me, are you clear about this? Yes. Yes, Vedas, are you clear? Why the pipeline is implemented? A complete operation is subdivided into sub operations, and these sub operations are carried out simultaneously. So if you want to perform large number of operations, this is particularly beneficial because each operation will be performed for 1 clock pulse only. So this improves the speed of operation. Okay, are you clear about this? Yes, tell me. Yes, students.
Yes, ma'am.
Okay. Now, once again, I am going to share screen with you. And here you can observe the pipeline stages used by ARM 1176 JZFS type of processor. Okay. Now, here you can observe how many stages are there. 1, 2, 3, 4, 5, 6, 7, 8. 8 stages of pipeline are used here in implementing parallelism in ARM processor. Okay, so here you can observe the first 2 stages are fetch stages, first fetch and second fetch. Third phase is instruction decode phase. Okay. And the next phase is register read and instruction issue phase. And apart from this, remaining three pipelines, they are called as data path pipelines, and they include ALU, okay, arithmetic logic unit, and shifter, and what is called as saturation pipeline. Okay, so these three things are there. One is called as a shifter, another is arithmetic logic unit write back value, and last one is the saturation value. Apart from this, you can observe here MAC 1, MAC 2, MAC 3. So meaning of MAC here is multiply and accumulate. Multiply